Today we're first going to talk about perfect square factoring, and then we're going to put all our factoring methods together and kind of go through what steps we need to do. So, perfect square factoring is, if you remember our FOIL method, if we had something like a plus b, the quantity squared, we squared the first, multiplied the two together, doubled for the middle term, and squared the last. So now we're going to be looking for something that fits these terms. In other words, the first and last are a perfect square, and the middle is half of those, if you multiply them together. Or doubled those, sorry. So here again, if it's got a minus, it's going to be like this. So to check this, you first check, is this a perfect square and this is a perfect square? Yes. X and 9. If you multiply those together and double them, do you get this? No. So this would not be a perfect square factoring that we can factor. First one's a perfect square, yes. Last one is. If we multiply these two together, we get 12a and double it. Do we get this? Yes, it is. So this is a yes. And it's not even asking us to go ahead and factor them yet, so we'll save that for later. 4y squared a perfect square? Yes. 121 a perfect square? Yes. And if we multiply those two together, we get 44y. We have not doubled it, so that would be a no. Is 2c squared a perfect square? No. And that would be it then. So this would not factor as a perfect square trinomial, which is really all the question is asking. It's not, will it factor other ways? Perfect square? Yes. 3n. Perfect square? Well, it's in the wrong order, so we need to kind of change the order here first. So it would be 7. 21n doubled, 42n, so this is a yes, so make sure you check your order. 5a would be the square root of that. 12b, multiply those together, that's 60, double it, you get that, so yes. So this is a perfect square trinomial. So this part didn't ask us to factor it, it just asked us to check on them to see if it would work. Now we're actually going to go through the steps of factoring. So anytime you see a problem now, these are the steps you could ask yourself. Does it have anything in common? So that's a really important one to make sure you start asking that. Is it a difference of squares? Remember, perfect square minus another perfect square. Is it a perfect square trinomial, what we just went over? Now, technically, you don't have to know this one because you can get it on your guess and check or however you're going to group, or the grouping method is also the other method we use on this. Okay? And if that is, look at the multiply the two together and then group. 4 terms, you're probably going to try grouping. So get in the habit of looking through all these steps as you go. So in number 1, is there anything in common? No. Is it a difference of squares? No, it's not a difference. Could it be a trinomial square? Possibly. So we got an x and we got a 2. Multiply those two together, double it, yes. So we're going to put our plus, and then don't forget your squared on the outside. And again, if you double check that, write out and use a FOIL method or something. Is there anything in common? No. Is it a difference of squares? No. Is it a perfect square trinomial? Possibly. We need a 2x there and a 5 here. Multiply the two together, 10x, double it, we get 20x, so yes it is. And square it. Anything in common in number 3? No. Is it a difference of squares? No. Is it a perfect square trinomial? Well, possibly. 3y and 2. That's 6y, double it, we do get that. This one, though, should be a minus, remember, and then the squared on the outside. Anything in common in number 4? Yes, there is. So we're going to factor the 4 out, leaving us x squared minus 9. And what do we notice about that? That is a difference of squares, so it factors into x minus 3, x plus 3. And then ask yourself, is that factored? Yes, because you can go more than one step in factoring. Okay, anything in common in number 5? No. Is it a difference of squares? No. Is it a perfect square trinomial? No, that's not a perfect square. So we're going to try our factoring method, either the guess and check or multiply these two together and go from there. So that would be 150. So we're looking at factors of 150. The signs need to be different, so they're going to differ by 5. So I think we can use 15 and 10. So it would be 25x squared. And the 15 needs to be positive because the 5 is positive. So plus 15x minus 10x minus 6. Again, if we group the first two and plus negative, group the next two. Here we have a 5x in common, leaving me with 5x plus 3. Here, if I factor out a negative 2, it leaves me with 5x plus 3. So I factor that whole thing out, 5x plus 3 times the quantity 5x minus 2 would be my solution. And again, double check and make sure those don't have difference of squares or anything in them. They don't, so we would be done with that one. Is there anything in common here? Well, 3 of them have 2's, but I don't think they have anything necessarily all the way in common. So we're going to group them, and again, you can move them around if you want. I think it's fine just to group here the first 2, make sure we do plus negative, and group it like this. So what do these first 2 have in common? They have an m squared, leaving you with 3m plus 2n. What do these have in common? A 4, but I'm going to factor out a negative 4 so I can get my signs right, leaving me with 3m plus 2n. So now they have that 3m plus 2n in common, leaving me with m squared minus 4. Hopefully you notice you are not done yet. That's one thing you need to think of before you finish. Is there anything that can factor? Yes, this is a difference of squares, so it'll factor into m minus 2 and m plus 2. So it's really important to make sure you factor completely.